engineering is a great place to study the techniques for human-centered data science, because you will learn not just about the technical field, but also about the human-centered approach and why it's important to center the human in this type of work.
Wow, Cecilia, this was fantastic. Thank you so much. Oh my goodness, even as the MC, I'm very much enjoying this. So this was great. Thank you so much. So we are actually going to switch over. Next up, we have Smrati Gupta, and she is a lead data scientist from Microsoft, and she'll be presenting design principles for personalization with ethics. Smrati, just a quick reminder to please set your timer.
Hello, yeah, can you hear me?
We can.
I guess that's fine. Okay. Hi, thank you very much. Thanks, Cecilia. That was a great talk. I'll turn on my timer. So hello, everyone. Firstly, thank you so much for having me over. It's an honor to speak at this particular conference. A little bit about me. I'm Smrati Gupta. And looks like the slides are not moving. Okay, yeah. A little bit about me. I'm a lead data scientist at Microsoft Xbox. I am currently working in Mixer, which is one of the gaming video streaming platform from Microsoft. My PhD was around complex networking protocol development with the European Space Agency. And since then, I have been involved in data-driven research at both academic and industrial level, as you can see over here. And currently, today I want to talk about something which has touched various aspects of almost all the projects and research that I've been involved in so far. This is around the design principles for AI-driven systems. And the idea over here is I'll be talking about, as data scientists, what are our ulterior responsibilities while we are designing the systems that are essentially influencing the society at a very perennial level. And the example that we're going to talk through is recommendation and personalization, because it's one of those AI applications which are quite user-facing. And today, almost every big tech giant is heavily relying upon them. So when it comes to personalization and recommendation, we have a simple story to say, right? Like we have the users and we have the content. And as a data scientist who's developing recommendation engines in the field, you need to find the right content to the right user, taking into account the different context associated with it, the different, the context associated with it, seasonality, novelty, and all the other aspects which are associated with designing the right data science model for recommendation. So the ulterior motive is to get the users to like the product that you recommend to them. And as a data scientist, when you're starting the design of such systems, you need to keep in mind like few fundamentals. And these fundamentals essentially start with what are the correct user signals based on off of which you can drive your recommendation engine. So they could be implicit user signals or explicit user signals. Is the user implicitly telling you that, yes, clicking on some content is helping you, or is it explicitly telling by writing reviews or clicking on the like button and so on and so forth. The second aspect of this is optimization metrics. And once you know how the user is reacting to your recommendation, what's the right optimization metrics that you want to chase after? And eventually your goal is for both of these aspects to work in cohesion to drive your business KPI, which could be as simple as revenue or user satisfaction, or could be more complex like retention and a little more complex KPIs, which cannot be directly mapped to signals and optimization metrics. So the question is that, sure, these things are the building blocks and they need to be clarified, but eventually you have a bunch of libraries available, different algorithms, and the space has evolved phenomenally in the last few years. And there are different solution families. You can pick up filtering algorithms when you kind of identify similarity between the content to recommend the next best content to the user, or similarity between the user to recommend the same thing. And these are the family of solutions which we identify under filtering. And this taxonomy in this is in no way exhaustive, and there's no like complete taxonomy of the space any which way. But the other aspects are using latent factor models. So for example, can we use the factors which are not explicitly driven, but can we use matrix decomposition methods to identify the interest of the users that are partially contributing towards the content choice. Then we of course have ensemble approaches, which are a combination of multiple models together, or reinforced learning approaches, which is the newest and the greatest, meaning to say, can we learn what the users likes online and adapt our system to it. But these pieces are fine in terms of the data scientists get a lot of choices in identifying these pieces. But eventually you want to measure your the quality of your recommendations on the basis of some primary quality metrics like accuracy. How well were you able to predict that a user who's interested in matrix will you know, give a 3.5 stars to Game of Thrones, right? So how accurate is your prediction of user interest? How accurate is your prediction? And in typically top-end recommender system, which we are talking about here, out of 5 best content pieces that you recommend to the user, how likely user is going to choose one of them? So hit rate has to be maximized, and coverage, like what percentage of the user and item pair have you been able to cover through your recommendation engine? But then there are secondary quality evaluation metrics that I really want to stress upon. And as data scientists, you are typically, you'll most likely be evaluated on the basis of your hit rate or accuracy. But these are the other quality metrics which you need to be aware of in order to design a holistic recommendation engine. So for example, diversity. Is the recommendation you're making diverse enough, or you are kind of pigeonholing your audience towards one type of content? How much of novelty is associated with your recommendation? For example, something which is super popular, is it popping up the entire space, or is the user having enough of balance between something that is that was popular 6 months ago and it's you have certain serendipity of this to appear as your recommendation? And the third aspect is churn and responsiveness. This is actually, again, 2 sides of the same coin. At what point do you know that your recommendation is being thrown too much at the user? Like what is showing it way too many times, as well as how quickly should you react to the user not liking or liking your recommendation? So how sensitive or insensitive your recommendation engine should be towards the user feedback. So based on these quality metrics, sure, we want to maximize all of these, but based on these, what are exactly our principles based on which we should develop our AI systems, and in this case, particularly personalization? So the first and the most important thing is, I can't stress this enough, that as data scientists, it's our responsibility to develop these systems, especially the ones which are interfacing with the humans, with the users, because these are powerful methods to influence the choices of the society overall. So it's important that these recommendation engines are fair, and they don't have an inherent bias towards a certain type of content. Now, this is okay in principle, but when you want to apply it tangibly, there are multiple methods. You need to minimize the known biases that you have in the data. If you're adding any updates in your training set, the bias test should be, there should be pressure tests for the fairness of the data that you're adding up. Especially during A/B test, you need to ensure that the distribution of recommendations is well aligned and is well spread out, so that you're not skewing the data towards whales or creating some unnecessary favors towards a particular content. And the second aspect of the same thing is, apart from fairness, you also need to ensure that is your data, is your model inclusive enough? Are you providing same quality and quantity of recommendation for your entire population? Is there any inherent bias in the way your recommendation engine is functioning, especially in terms of representing all the different sections of the society? And truth be told, you never will have enough of data to represent every single section of the society. But an awareness towards the skewness in representation is of paramount importance as data scientists, because you do have control over the kind of bias, you do have the knowledge over the kind of bias that this ecosystem is bringing. The other aspect is transparency and privacy, and I kind of also see it as 2 sides of the same coin. we should be able to develop recommendations behind which we can stand. So although we are relying on complex, especially latent factors methods, they are super complex in nature. But as data scientists, we need to be able to explain why a recommendation is surfaced to a user. And therefore, disclosures should be very well understood and implemented to ensure transparency. And at the same time, we should be ready to understand the privacy and data usage of the users. So the users should be, the data we are using to design these engines should be permitted, should be following the data privacy laws that are in place. And this is very important from data science design point of view. So understanding these broad principles is one part of the equation. And the other part is, what are the practical considerations that they surface when you're actually designing? And there are some fundamental design considerations which are always taken into account. For example, cold start problem. What do you recommend to a new user? Use the wisdom of the crowd, recommend popular content. What do you recommend to for a new item? Use similar attributes or randomly explore the content. Temporal effects. You don't want to recommend the users a Christmas tree during June, right? So the temporal effects and the trends should be taken into account while designing these. But I want to talk more about the design considerations which are more pertaining to the principles we talk about. As data scientists, every recommendation engine that you design should have a cohesive list of stop words, which are important to take into consideration. The reason being that recommenders manifest the societal taste, and it's important that we do not amplify the tastes that have potential to cause widespread crisis. And these are well-known fundamental stop lists, like legally prohibited content and terrorism, drug use, religious extremism, and so on and so forth. It's important also not to use this to polarize the opinions. So these things should be in place for sure to ensure that we are not creating crisis content in the ecosystem. The other part is filter bubbles, and this is extremely relevant because recommenders have the powers to reinforce the existing choice of the users. And imagine that if we are aware, as business KPI maximizers, we will be aware of the fact that showing a particular content to the user is super important and of paramount to the business. But from ethical standpoint, it's also important that our human creativity is preserved. So there's enough of room of exploration, there's enough of room of diversity. So because if we kind of pigeonhole our users towards a particular type of content, there's very little area left to explore and to learn new contents and let the humans develop new tastes. So excessive engine dependency is also a problem in this whole ecosystem. Of course, outliers have to be considered during the design process. We should not design systems that are extremely overweighing the, for example, the reviewers, which are professional reviewers, because then you give a lot of power to a very few number of people, and they can easily polarize the entire opinion set. They can, give undue advantage to a certain content, and so on and so forth. Bots may pollute the data, large buyers may cause skewness. So feedback should be very important in recommendation, but feedback from the right sources and weighing the feedback equally across the board is very important. The other consideration is gaming the system. So for example, we talked about the fact that there should be transparency in recommendation, but it should not be so easy to interpret that the users can come in and game the system. Now, this is important because intentional gaming, it can easily skew our systems by the users who want to promote their agenda, their humor, their ideology. And this, as data scientists, it's our responsibility to develop systems which are resilient against these kind of activities. So, for example, one easy way is to rely on creating far more reliance on the signals that are definitive of the user interest, and that's almost never the click data. We need to ensure that our system is resilient towards quirks of the human behavior, and always relying on signals that are definitive of the interest of the users. last but not the least, as data scientist and as somebody who's designing recommendation engine, it's extremely important to be empathetic towards the consumers of it, empathetic towards the local cultures, local laws. So you might design an absolutely fantastic recommendation engine, which is super for North America, but there are different quirks in the society in Germany or in India or in Asia, other parts of Asia. And it's extremely important to be empathetic and respectful towards the culture, optimize the stop list towards the culture, optimize your guardrails towards the culture. And that is a responsibility of the data scientist. So with this, I hope I have not, yeah, I'm almost there, 30 seconds to my advantage. But what I want to convey through this talk is we, as data scientists, have a lot of power towards influencing the society. And therefore, it's important to have ethical design principles from the very beginning in the structure, so that we do not end up creating polarization in the society knowingly or unknowingly through these mechanisms. And I guess.
Yes, I can do a quick transition to the Q&A. Thank you so much for this great talk. It was fantastic. So we'll transition to Q&A. For those attendees, remember to upvote the questions in the Q&A link that you would like to see answered. And there goes my timer to remind you.
Okay, I see the questions here. You discussed making sure that your model is not biased in the content that it recommends. How do you set threshold or expectations of what is fair recommendation distributions? Or absolutely. So the thing is, in this kind of thing is extremely dependent upon the domain over which you which you're working. So typically you have to look at the distribution of your entire content and look over the temporal changes in those in the way this content distribution has behaved. The threshold should definitively never be put on the basis of percentile, but it typically works. There are multiple ways to do it, but it typically works to calculate the margins of percentile change across temporal piece. A/B testing is a fantastic way to test different thresholds and see if the fairness element is being complied upon. User research is phenomenal in some of the user-facing activities. Gaming, for example, it's important to do user research and, if possible, in a scalable way, get feedback in a fashion that you have some, some squad or some of your consumers who are able to give you those kind of feedback. When you say get feedback from right sources, could you give us the criteria of the right sources? So, again, these questions become very domain related. For example, we do have, I can speak to, you have to understand that exactly what are your modular channels of feedback to begin with, and look at the distribution of inputs and outputs out of your modular channels. So one of the activities that we end up doing is relying on the sources of feedback on the basis of the distribution of their inputs and the output channel. For example, a reviewer, a reviewer of an e-commerce site, balancing between the number of purchases made by this reviewer and the number of reviews given by this reviewer. There is a fundamental metric that can help you or develop reputation towards it. Over a period of time for the product, you need to look through these reputation metrics and decide that what all have been the sources that have been reliable in the past and what all are most likely to be unreliable or create polarization because of past behavior of the users. So that could be one way I see. Other questions. Yeah, do you have examples of platforms that you think are resilient and manage the anti-crisis content fit? Basic answer is, again, depending on your domain, but you need to look at multiple open source libraries that have been made available in the past, especially if you, I'm not in a position to name a few of them, but a lot of cloud services have started even offering methods which are able to test the out-of-the-box amount of bias in the data. Microsoft has a bunch of undertakings around it as well, that are we ensuring that fair and ethical AI principles are being met. And in spite of apart from some of the Python libraries which are available, you also have to look into some of the best practices that are being definitely concurred with across the board in the industry at this point. Have I covered it all? I'm not sure. Kristen, can you help me?
So if you've answered it, you can just select answer live. And I think one person asked if your slides are going to be available afterwards.
Do we have a portal within the, I guess you guys can answer that better than me.
Yeah, so we'll